just to make sure everything is crystal clear here. Remember in polar land, when it tells you they intersected these 2 points like this and like this, the theta values they're giving you are this theta value, right? And what's the other theta value they're giving you? That theta value right there. The 2 angles from the positive x-axis. From the positive x-axis. This is key to remember. Okay, so then it asks, let S be the shaded region. Find the area of S. Now, can someone give me one key observation that would make this a little easier? So first of all, hold on. Yeah, that's actually a really cool observation. So first of all, r equals 3. What is r equals 3? Circle with radius 3. So that's a circle with radius 3, and that is this one right here, right? I mean, you can write it out if you want to be x squared plus y squared equals 3 squared. You don't need it, but that's what it is. So one way to do this instead would be to take that and then subtract the top part.
Yeah.
You see what I mean there? You could do it that way, right? So let's just take a look at this region for a second here. Let's just take a look at this region. Again, are there going to be many different integrals you could set up to do this one? Absolutely. It's kind of cool this way. I think this is my theory as to what would be the easiest way. It might not be the way they do it, but let's just see. So what region are we really interested in? We're interested in this region, right? So when you're looking at a sector for this, and I'm going to just take away these just so I can make it a little less busy. When you're looking at a sector for this, remember, all your sectors are emanating from the origin right here, right? When you're looking at one sector, like here's one of them, right? You're looking at that whole sector, right? But then what are you taking away from it? You're taking this away, right? You're taking that away. So we're trying to find the upper part so that we can take it away from the circle and get the shaded part, right? So what's the whole, circle with radius 3 is going to be pi times 3 squared. And we want minus green, right? That's what we're doing right now. Are we good with this so far? So how do you go about finding, we need to find, so every time we do this, we're looking to find the area of which the end cap here. You see this end cap right here? That I just shaded in right there. That's what we're looking to add up. So how many radii are we looking at? We're looking at the big radius minus the small radius. So the big red slice right there, the big red slice is 1/2 3 squared d theta, because it stays the same. It's the circle radius, right? But what's the smaller radius here? 4 minus 2 sine theta, right? So what's this one going to be? 1/2 4 minus 2 sine theta squared d theta. What can I factor out of both of those? The halves, right? So what do you have here? You have this 9 minus 4 minus 2 sine theta squared d theta, right?
Yeah.
And you're integrating that from what to what?
Integrating that from.
It tells us the limits, right?
Pi to 6.
Pi over 6 to what?
Pi over 6 to pi.
So here's another thing. What do you notice too about the green shape?
That is from.
It's symmetrical. It's symmetrical across the line. X equals 0, so it's symmetrical across the y-axis. So instead of going from pi over 6 to 5 pi over 6, what could you do? You could do 2 times from 5 pi over 6 to what?
2.
Sorry, pi over 6 to pi over what? Does it really matter too much?
No.
Not so much. Not so much. Is this a calculator one or a non-calculator one? This is a calculator one, right? You kind of like that because what do you know about integrating sine squared? No, it's not like, yes, you should cackle, it's fine, but is it possible? Like, you can do it, right?
Yeah.
It's not the best thing in the world. You can do it. They're looking for the setup here. So I'm just curious. Oh, so we know that the particle is on what path? R is what?
R equals 4 minus 2.
2 sine, sorry, thank you. So then what do you do with this? Yeah, so we just do the substitution, like into there. Is that what you're saying?
Yeah.
So we have x is equal to 4 minus 2 sine theta times cosine theta. So now we have x just in terms of what? Theta. Nice. So then what do?
And then you know that theta equals t squared. So
you know theta is equal to t squared? Okay. So you want to take theta is equal to t squared and plug it in right there? So what do you have here? X is equal to 4 minus 2 sine theta. Oh, not sine theta. Sine what?
T squared.
T squared times what?
Cosine t squared.
Got it. And now what do you do? So now you know the particle position when you want to find the time t, right? So could you have solved for theta and then just square rooted it?
Yeah.
Or, yes, square rooted it, yeah. So now you have 1 is equal to this thing. Now when you see this, what's negative 1? What should you think when you see this? Come on, what's your response when you see this and you have to solve it? Please, oh please, use your calculator.
Yeah.
Please, like you guys are better at you guys are better at a lot of algebra than I am. So maybe you could tell me how to do this by hand, but like I don't see it. I mean, the only thing that I think of when I see this is like, please let it be factorable in some cool way. There are a lot of horribly difficult math problems that you'll come across. The saving grace is some sort of random factorization. Do you remember when you were taking pre-calculus and you're working with trig, some of the identities are proved with like adding and subtracting the same nasty trig thing?
Yeah,
you add and then all of a sudden it factors and the answer's like 7 and you're like, what? Where did 7 come from? You know, yeah, you're like, huh. But the thing is, my Hungarian professor would always say, you know, he would show us something, right? We would work on a problem for like a week. And then he would show us the proof and he'd be like, this is this, this is this, this is this, this is this. Like, done, right? And we'd be like, whoa, that is so elegant and so cool. And he would say in his awesome Hungarian accent, he'd be like, well, what I am not telling you. This line, it took him 2 years to see this line. You know, like, he said that all the time. And he really did talk like that. It was amazing. I actually had like the count as one of my, from like, y is equal to 4 minus 2 sine theta times sine theta. And we end up with, similarly, x is equal to, oh look, did we just do this? I keep on not writing the 2, I don't know why. 2 sine theta, cosine theta, right? Hold on, let's just finish this first, okay? So then it says, but in terms of what?
T.
So are we done?
No.
No, what do we know?
We know T squared.
Theta is equal to t squared. So then you're taking this in and you go, okay, so you know y in terms of t is equal to 4 minus 2 sine t squared sine t squared, and x of t is equal to 4 minus 2 sine t squared cosine t squared, right? So what did we now have? What is the position vector? There it is, right? You could just write it like this if you wanted to. That's fine. They will read your work, right? So there it is. There's your position vector, right? So what do we now need to find? So now we find the velocity vector at time equals 1.5. So what do you actually have to do? Differentiate. You have to differentiate this thing. So you're really interested in finding this. Y prime at 1.5, comma, x prime at...
Can we just write that?
Yeah, you could. I'm pretty sure you can. So what can you use? Is this a calculator question? Yes.
Yeah.
Look at the grading rubrics that I've given you. Do any of them say, like, some of them when it asks you, like, if the question says show reasoning, there will be a point to what? Show your reasoning, right? But does this say, like, show your reasoning? You need to always show what you're doing, right? So you could just say this is what we want, right? So what function could you use on your calculator? N deriv. We're not integrating, right? It's math 8 instead of math 9, and it's the same thing except you don't need a lower and upper bound. What do you need? Just the number, right? So use n deriv. Let's just see. I'm curious. What do you notice about the answer right there? There's 2 answers. Why are there 2 answers? Truncating and rounding, right? Look, there's 1 digit difference, right? Be really careful because that's a whole point. Like, look at that. You get 2 points for the position vector and 1 point for just the answer. You would lose that 1 point if you rounded incorrectly. So, James, correct. X, oh, sorry, A, right? Sorry, excuse me. X minus, correct, all over. 2 factorial, right? Correct. F of n, yep. Yep. Correct. Is there a really high degree of consistency in this? It should be. It's not like nothing's off by 1. There's no like alternating sign. It's just really consistent, right? So let's go back. So James, can you tell me what does it mean by, what does this mean? P1. What does that mean, James?
It's like the first term.
Does it mean, what does it mean exactly? Can
is it like
we could substitute if we wanted to, right? So what do we end up with? 3 is equal to f of what? 1/2 plus f prime of 1/2 times what? 1/2 minus what? Now, why did you know it was 0, Matt? It's a simple answer. Yeah, this isn't complicated. About x equals 0. So this, everybody sees this? This is your what value? This is your, what value is that? That 0 is, you plug that in for, where did we plug in 0? A. Yeah. What you center your Taylor polynomial around is the A value. Okay? So for this problem, all you're doing is you're plugging this in. Okay? I'm too big here. Sorry. So what do we have here? We have 3 is equal to f of 1/2 plus.
Then shouldn't the first term be 0?
The first term be 0. Hold on a sec. Hold on one sec. Accurate? Sorry about that. We good? What do we think? Are we good? Raise your hand if you can hear me. Raise your hand if you can hear me. There you go. Oh, we're alive. I know. Saturday morning. I'm going to do a little tap dance. I brought out my fancy shoes today. No, really, I actually brought out my fancy shoes. Okay. So, Tori, to do here. Tori, can you help me with this? P3 of x. The general form of that is going to be, and it's around 0. So A is 0 in this case. So it's going to be f of 0, right? Yes. Plus f prime of 0 times x minus 0 over what? 1 factorial. Plus f double prime of 0 times x minus 0 squared over 2 factorial plus f triple prime of 0 over times x minus 0 third over 3 factorial. So now are we just literally plugging stuff in? Yeah, we are. So we know, so P3 of x, f of 0, what was it? -4, thank you. And we know f prime of 0 was what? 2. So we now have 2 times x over 1. I'm overly writing it out so we can see the patterns. You lose some of the ability to memorize this stuff if you take away too much. At least in my opinion you do. Does it tell you f double prime? Oh, how nice of it. Times x squared over 2. I'm going to overly write it. I just like writing exclamation points today. F triple prime is what? 1/3? X cubed over 3 factorial. Now, what do they expect you to do with it? Technically, are you done?
Yes.
What do they kind of expect you to do? You need to simplify a little bit, okay? You have to do the basic simplifications. So you get -4 plus 2x minus 1/3, I think, right? 1/3 x squared, right? 6 plus what? 1 over 18? 18, right? X cubed. Is that it? I think we just found it. Is there anything else we can do to that? I'm pretty confident in this. Then can we write the general one out? Yeah, what does it look like? Oh, it's going to look exactly like this, right? Except we just have to take this right here,